I bought some things. Time for an unbagging video. Let's see what we've got here. An enclosure, a small piece of perf board, a jack socket, and a switch. If that doesn't seem like enough, it's because the rest of it is in here. This is the old audio amplifier that I made for my computer a long time ago. I'm planning to take it apart and rebuild it in the new enclosure along with the microphone preamp. I'll say more about that later. Now, while I was editing the last video, I noticed there was a bit of a whine in the background. So I'm going to increase the filtering capacitor from 33 to 470 microfarads and see if that stops it. Time to start putting it together. I started with the power filtering components, and I added some PCB pins for connecting power. Then I did some soldering. Yes, I need to get a bit of soldering on. I connected it to my bench supply and did a bit of a test. 11.94 volts, that looks about right. I connected the filtered supply to one of the rails across the top of the board, and then added the resistor that powers the microphone. And here I'm adding an input pin for the microphone. I connected the microphone to it, and then the scope to make sure I was getting a signal. Now time for the amplifier part. It's a bit hard to tell there, but I think it's set for 200 millivolts per division, which means we're getting about half a volt peak to peak. That should be fine. The next thing was to take the old amplifier apart, and then unsolder the terrible rat's nest I created last time. Hang on, I should be playing the soldering music backwards here. While past me is doing that, I'll explain what the plan is. This is the way the old amplifier box was wired. I was running it on an unregulated plug pack, so there's a bit of filtering up here. This diode is for reverse polarity protection. The plug pack had a reversible polarity and it wasn't very clear which way was which, so there was a chance of getting it wrong. This socket here might be a bit surprising. I wanted to record audio from games, and I found the most reliable way of doing that was just to feed the output back into the input. The plan is to add the microphone preamp in here, with the socket for the microphone input and a switch for selecting between the microphone and the loopback as the recording source. Well, it looks like I've finished dismantling things. And this is me trying to figure out how to lay things out in the new box. Why is it that I always manage to pick an enclosure that I think will have plenty of room in it, but it turns out just to be barely big enough? Eventually I decided on this layout. Next I designed some layouts for the front and back panels. I printed some drilling templates, cut them out, and glued them onto the panels. Then it was time to drill some holes. Thank goodness for stepped drills. I don't know how I ever managed without them. Then I did a test fit of all the sockets and controls. It was going to be a bit of a squeeze fitting this part in. There was plenty of space left on the preamp board, so I decided to rebuild it on there. I replaced that clunky old capacitor with a newer one while I was at it. I didn't need the drilling templates anymore, so I took all the sockets off, removed the paper and then put them back on again. And that's the back panel finished. At this point I connected the plug pack to see if the new filter was working. But it seemed like it wasn't. I was getting over 11 volts at the input but nothing at the capacitor. Everything looked like it was connected properly. I scratched my head for a bit and then decided to check the polarity of the diode. It seemed to be the wrong way around, which was odd because it means the diode would have to be marked in an unusual way. But it was a very old one out of my junk box, so who knows. So I took the diode off and turned it round, and then plugged in for another test. I was getting something this time, but not as much as I expected. I disconnected the rest of the circuit in case there was a short somewhere loading it down. But it didn't make any difference. After a fair bit more head scratching, I eventually noticed that the leads were plugged into my meter the wrong way around. So I swapped the polarity of my plug pack. I'd changed it earlier off camera, because my metering mistake had led me to believe that when I rewired the power socket, I'd picked a different standard to the one I'd used originally. But it turned out I was right the first time. So then I had to put everything else back the way it was. I considered replacing the capacitor, but it didn't seem to be too badly damaged. So I just put it back in. Hopefully it'll reform itself a bit if it needs to. With that little diversion out of the way, I could get on with the wiring. I checked that I had the power wiring correct. Then it was time to hook it up for another test. That looks about right. Next I wired up the output amplifiers. So as not to create another rat's nest, I used pins to make all the connections to the boards. At this point I decided it would be a good idea to fix the boards down, so I drilled some holes and put some screws in. Then I carried on with the wiring. Here I'm testing the speaker outputs. Looks good. That looks good too. Here I'm wiring the loopback connection to the input selection switch. I forgot to wire in the power switch earlier, so I did that next. I'm testing the volume control here and something isn't quite right. That's supposed to be zero volume. I thought there might have been a short somewhere in the potentiometer connections, but that wasn't it. After some poking about, I found that the angle that the wires were coming off the potentiometer were putting a bit of a strain on something inside and making it flaky. So I reattached them at a better angle. Here I'm testing the input selection switch. Everything seems to be working, so it's time to put the lid on. If I can fit all the wires in. It's only a mouse nest, shut up. The most satisfying part of any project, screwing the lid on. There's one more thing I wanted to try. The output had always had a bit of a hum to it because of the unregulated plug pack I was using to power it. So I thought I'd try replacing it with a more modern regulated one. This is the ripple I was getting at the output with the old supply. And this is with the new one. Quite a big improvement. I think I'll be sticking with that. I didn't want it skating around on the table, so I took the lid off again and added some rubber feet to it. I plugged it all into the computer for some more testing and discovered another problem. There was a loud click every time I moved the input selection switch from one position to the other. That's because the output of my microphone preamp has a DC level of about 6 volts, resulting in these big transients. So I added an output coupling capacitor. After that, those switching transients were completely gone. The final thing I'd like to do is put some labels on the panels. But my old Dymo label scruncher isn't quite going to cut it. I'd rather have something with a smaller font. So I got a more up-to-date model. 2 unboxings in one video. You're getting a bonus. This looks like a manual, but it's really just a pamphlet telling you how to download the manual. I guess they figured nobody's going to read it anyway, and not reading a pamphlet uses less paper than not reading a manual. They give you a tape cartridge with it, that's nice. Supposedly this one provides a range of type sizes, so let's see how it goes. I decided that the second smallest size would be about right. Then it was just a matter of trimming them and sticking them on. There's the front panel finished. And through the magic of video editing, the back one too. And here it is installed on my desk. I might try to get some white on black label tape sometime and redo it. But for now I'm going to call it done. Well, that's all for this project, but don't worry, I've got plenty more ideas, so I'll see you next time.